Thank you. Good evening to all. My name is Irfan Hussain and I am a master's student at GIK Institute of Engineering Sciences and Technology in the field of computer science. Currently working on HSC NRPU funded project of aerial video surveillance and tracking. So today I will show you how to train your own custom data on YOLO. Nowadays, many people train their own custom data on YOLOv5 and become a contributor in the field of computer vision, or we can say in the field of robotic vision. Train a data set with on YOLOv5 model. Basically, I am currently working on a new project of aerial video surveillance, and I use Visdrone dataset to train model. So from this link we download a Visdrone dataset. To utilize presentation time, we use that file having less size. So we use YOLOv5 dataset to train YOLO model. So I already download from this site. So I have already downloaded at this directory. So first we need to extract the file. So let's start. So go to this directory, check the directories. So here and go to the directory where we have a zip file of YOLOv5. So check the directory. So cd Visdrone dataset. So let's check again the directory. So we have a zip file of Visdrone-2019 DET wall. So first extract the file. So for extract the file, we write a command .xf Visdrone. So let's check. So we have a file of Visdrone having images and annotations. So let's check the annotations. So there is 1 2 3 4 5 6 7 8 values. So let's check where there means of the value. Visdrone dataset label. Here is the description of annotations. So the first value bounding box left means X, the second value bounding box top means Y, and the third value width and height. So as you know that YOLO format is like that. So we need a class ID X Y width and height. So we need 5 values to train YOLO. Class ID, X, Y, width and height of the bounding box. So basically the four information X, Y, WH is the information of bounding boxes. So we need from Visdrone bounding box left, bounding box top, bounding box width, height and class categories. So there is objects in image, there is object in Visdrone dataset having people, bicycle, car, van, truck, and there is a class ID of that objects. So we have Visdrone dataset having annotations and images. So for utilize time, we write a code already. So firstly we will convert a visual drone to VUC format, Pascal VUC format. Basically Pascal VUC format, we want to convert the text file into XML file where there is easy to convert VOC file, Pascal VOC file to YOLO notation, YOLO label format. So you can use online tools for VOC, for example, such like that. Use VOC, VOC to YOLO format, VOC to YOLO format. So you can use by drag and drop the annotation files and convert into one format to another format. So you can change to Cuckoo Johnson to Pascal VOC XML, VOC to TensorFlow, TF record. In this website you can use to change VOC file to any format. We can go to CD. So let's check the file. So we have annotation, new images. We make two new directories to save new XML file, new VOC files. We will generate from annotation of Visdrone, and on the corresponding of that image we save their images on another folder. So make two directories, make dir XML annotations to annotations. Let's alright. Make a directory, new images. So let's check. We have two directories, new images and new annotations. So let's go to the code. So we have visual drone images. So input images and annotations, and output folder XML annotations. So we save their name and put it here, and images, put it here. So basically the code working, there is the objects of Visdrone and there is ID. We need that ID for YOLO training, and here there is object segment. Where in object segment there is a name of the object and their object bounding box values, and here there is a file name, path, image size, width, height and depth, number of channels, and write them into XML file. So let's run the file, Ctrl S. So let's check again. Information of objects, their path, their bounding box values. So here we check. So new annotation, we have XML files. So the XML file we get segment car, their bounding box values. Alright, so now we change the XML file into new images, and we do not need the rest of images, rest of folders. So we need to XML files. So XML annotation files are moved to new images. So X copy XML annotation to new images. So now let's check. So new images, we have XML files and with respect their image. So we do not need rest of them. So we want to remove directory recursively or delete annotations. Yes, that's fine. and remove images. That's fine. And remove, let's check what is remaining. New images, XML notations. So we remove XML annotations. Yes. So cursorily annotations. So now we have two files, new images and annotations. So to remove annotations, we have remove recursively annotations. Yes. So we have new images file having images, Visdrone images and their annotations. So we do not know this file, so we also remove the file. Delete .ts file. So we also remove that file. So we have new images files having images and XML files. Change. So now we are change new images files into YOLO format. So for YOLO format, there is two type of values. You can see normalized values, or you can see non-normalized value. For normalized value, we divide the size by 1 divided by the size, width and height for x and y for center point of the image, and at last we have x, y, width and height value of the bounding boxes. So YOLO Python VC to YOLO. Let's check it. What's happened? So here we have YOLO file in YOLO format. Here there is ID, class ID, object ID, and there is a 4 normalized bounding box values of the bounding box. So let's check the code. So firstly we extract the bounding box values from XML file and write and so we have get a value of size, width of the image, and in object we get the values of bounding box values and normalize it, and then convert into normalized bounding box. So now we have YOLO format label of that respective image and their XML file. So we do not need XML file, so remove the XML file, delete recursive all XML file. So we can delete the XML file. So now we have images and their YOLO notation format files, text files. So now to feed dataset, we have make a new directories for training for images, for training and validation. So for this directory we make new images cd. For this directory we make new directories, make dir images and make directory labels. It's fine. So we have two new folders, images and labels. So with images we have need two files to feed YOLO, train and validation. So make two files inside the images. So cd images, make directory train and make directory validation such like that. We make the same directory check. So here is images. There is a two folders, train and validations, and there is a another folder called labels. So train, the two folder train and validation. Basically YOLOv5 need that type of directories to train your model. So in image folder you store images with respect. You can split images by your own choice according to your own situation. So the code working about train ratio 0.8 and count for train. So for train we have the dataset, the images and files in new folders. 80% of them are count, and then we within for loop we send a training path images and XML path and send XML files to XML path.txt on this, similarly to validation. So for validation we multiply with ratio with respect to ratio. 20% of it are sent to, so for validation sent to wall path images and wall path text to send split. So total will be 5480. So train directory 219 and 14, 80% and 20% we are sending the train for 38 images and validation 24 images. Make a directory Visdrone Dataset 1. So here is the Visdrone Dataset 1. Move images to Visdrone 1 and move labels to Visdrone 1. So now the dataset, the pre-processing is completed of Visdrone dataset, and now we will feed to YOLO algorithm. So is ready to feed algorithm to train YOLOv5 algorithm. So YOLOv5 by default, YOLOv5 train on Coco dataset. They have a link of Coco dataset, and by default they are starting training on the Coco dataset. So we need to give some path to algorithm to train our dataset. So we create a file, drone.yml file, where we tells to the algorithm, to the YOLO, to train that part of datasets. That part of dataset, number of classes mentioned and number of classes object are mentioned. So train dataset, we give this path. So we give the path of drone.yml where the path of our dataset. So let's start the training. So the training start. So we analyze per epochs to interactive results through TensorBoard. Here is the result where I trained before. So stop the training, and we test our images, by giving the source path of images, the testing of our model. So here we'll test, stop this one, and we can check. So this is the dataset of our NRPU funded project HAC related to surveillance, which I use DG Phantom drone Mavic 2. So they are localized, they are test on visual drone dataset. So the result of the visual drone dataset. So So when you train your own model, your own dataset, or your model, so use the annotating GUI which available in GitHub, and you can annotate your own images, such like that. So download from GitHub and annotate your own dataset and feed to YOLO. So such like that. So the GUI save your annotations in Pascal VUC format and YOLO format. Let's change in YOLO format, and easily you annotate your images. So easily annotate your images. So here is a cam file name child cam 10. So this is a child cam 10 child cam 10 image, and here there is a bounding box value, normalized bounding box value. So by feeding your own dataset, and changing parameter of YOLO models, and even you change the architecture of YOLO model, and you become a great contributor in the field of computer vision. So thank you. That's it for my side. Thank you.